Hello, today I will present our ICCV 2025 paper titled MAVFlow, Preserving Paralinguistic Element with Conditional Flow Matching for Zero-Shot AV2AV Multilingual Translations. This work focuses on direct audio-visual translation across multiple languages, aiming to preserve non-verbal information such as speaker identity and emotions, which are often lost in conventional translation systems. In dubbing scenarios, translation must handle both audio and visual modalities. There are two main reasons for this. First, if the speaker's identity is not preserved, user immersion decreases. Second, when lip movements are not synchronized with the audio, it can affect speech perceptions, as demonstrated by the McGurk effect. Therefore, we need a model that can perform simultaneously audio-visual translation while preserving non-verbal information, such as the speaker's original identities and emotion. Such translation can be performed using a cascade systems that integrated various existing models. For example, one could generate a transcription using audio-visual speech recognitions, translated it through a neural machine translation systems, and then use a text-to-speech model and a talking face generation model to produce the voice and face. However, these cascaded systems have limitation in preserving the original speaker voice characteristics, emotions, and utterance durations. In addition, they inevitably introduce intermediate text representations, and frequent conversion between modalities often lead to information loss. To overcome the limitation of such cascaded models, an audiovisual translation model called AV2AV, which used units instead of text, was introduced. AV2AV was the first model to propose direct audiovisual translation. However, it employs a simple architecture where the vocoder and face renderer are completely separated. As a result, it failed to preserve non-verbal information from original speaker and underutilized the visual modality. Therefore, we propose MAVFlow, a textless framework that integrates audio-visual modality to preserve paralinguistic information. This textless-based direct audio-visual translation approach effectively preserves non-verbal information by leveraging emotion cues from the visual modality and speaker cues from the audio modality. The architecture of MAVFlow consists of four main components: the unit extractor, unit-to-unit translation model, conditional flow matchings, and last, the decoder. First, the unit extractor and unit-to-unit translation models, which handle the core translation process, utilize components from AV2AV. Next, the duration length regulator serves two purposes. It interpolates the generated audio to match the durations of the original source. It maintains audio-visual alignments in real-world dubbing scenarios. This is particularly important in actual movie translation, where the total runtime should not change, making it essential to preserve the duration before and after translations. Next, we adopt conditional flow matchings to provide guidance using embedding extract from both audio and visual modalities. Specifically, we leverage speaker-level audio embeddings and frame-level visual embeddings. For audio, it is beneficial to capture global speaker information, while facial expressions change on a frame-by-frame basis, which is why this approach is applied. As a result, MAVFlow effectively utilizes both audio and visual modalities, and the conditional flow matching model integrates them efficiently to preserve paralinguistic information. Next, I will present the experiment result using MAVFlow. First, we evaluate the generated audio. Compared to audio generated by text-based cascade systems, the translation quality may be slightly lower. However, MAVFlow effectively preserves utterance durations and paralinguistic informations. Moreover, MOS score comparison shows that MAVFlow produces more natural speech and maintains higher speaker consistency than the baseline. Next, we look at the generated visual results. Qualitative results show that frame-level visual generations effectively captures and reflect the original video's emotions in each frame. Additionally, the table confirms that the frames generated by MAVFlow have emotion embedding closest to the ground truth. Next, we present an evaluation study examining the effect of additional training on emotion-rich data and modality guidance. First, fine-tuning MAVFlow on emotion-rich dataset, referred to as MAVFlow Plus, increased emotion accuracy and emotion embedding cosine similarities. Previous results evaluated MAVFlow's gyro-shot performance after training on a general audiovisual dataset, while this evaluation study examines the effect of training on emotion-rich audiovisual datasets. Additionally, the evaluation study in Table 8 shows that using both audio and visual guidance improves speaker similarity and emotional accuracy, whereas visual guidance alone has little effect on emotion. Finally, we will show a simple demo of audio-visual translation generating using our model.
Pero yo estoy pensando en otro alguien que no tiene nombre y apellido. But I'm thinking about someone who has no name and love.
Thank you for listening our presentation.